Okay, well, let's begin. Welcome to the CIECAst. This is Fred Iantorno, Executive Director of CIECA. In today's CIECAst, Raj Pofale, founder and CEO of Claim Genius, will address why AI and photo estimates are needed in today's environment. He will also share how Photo Estimatics is bringing innovation to the claims and recycling industry. Raj is a senior technology executive and product development leader for more than 20 years, with more than 20 years of experience in large-scale enterprise platforms. With a passion for technology and entrepreneurial skills, Raj invented a disruptive AI product with the intent of making touchless claims a reality. During the webinar, if you have any questions, please type your questions in the webinar navigation pane. We will answer as many as possible at the end of the presentation. I want to thank everyone for spending their time with us today, and to Raj for sharing his insight and expertise with us. I will now turn this over to our presenter, Raj Pofale.
Hello everyone, thank you for joining this webinar, and thank you for CIECA to arrange this. More than technology, I think why I want to talk about the AI and the insurance industry is I think this is the industry where the most innovation is required, considering last 25-30 years this industry has done some changes but not to the level that they need. So can we go to the next slide? I think Fred already introduced me, so I think we can straight away dive into the presentation. So as Fred also mentioned, right, the vision of using the AI is obviously to make this claim process as touchless as possible. So now let's take a look at why it is so important, for the insurance industry to look at the AI as an option, as a disruption or an innovation. The crux lies in actually the problem statement. So as you all are aware, pretty much aware, that how this claim process in today's world is fairly manual, inefficient, right? Regardless of any of the accident, whether it is total loss or a medium impact accident, you have to basically report that claim manually. You have to basically tow these vehicles into the garage, where the garage is going to charge for the storages, the tearing down of these vehicles, the advance charges. On the top of it, there is a manual appraisal that needs to happen, right? And often it takes about 3 to 10 days, depending upon, of course, the impact of the accident. And it usually costs the insurance carriers about $400 to $600 per claim. Now, if you look at the volume itself in the US industry, let's talk about only, it's about 25 million auto insurance claims per year. And globally, if you look at it, is more than 80 millions. So looking at this volume itself, the losses that the insurance industry is going through or incurring is tens of billions of dollars. And that is the reason it needs this this kind of a technology and a disruption. Not only the cost savings, the process itself is pretty manual and inefficient, and that's the reason today's technology can bring a lot of automation in this space, and obviously brings more efficiencies. Next slide, please. So now, looking at the process itself, right? What are those different, loss expenses that the industry is going through? So there are storages, tear down, towing charges, replacement rentals, obtaining the policy reports, right? Doing the injury validations, adjuster service fees, tons of administrative losses which are allocated towards LAE, and there are a lot of others unallocated LAE as well. If you look at the total losses that we are looking at, is about $21 billion overall in 2017. That actually is about 13% of the premium that is getting collected. About $130 billion is the premium up to 2017. 13% losses are fairly high. And that is the reason it it needs some innovation. And if we can get eliminated, I mean, these losses are can be eliminated, where you would be basically reducing the unnecessary storage charges, the towing charges, and adjusters and administrative fees. Your losses can literally come down to 50%, which is significantly a great savings. uh, Alone in US, these savings can exceed up to 10 billions, and globally it is about 35 billions, just by doing the claim automation. So it's an potentially a very huge impact to the carrier's profitability, and that is the reason that we need this kind of an innovation. Uh, this video is going to be shared on the webinar, so you would be able to go through this number, and you can see how the premiums have been increased from 2014 till today. Uh, but I mean that this number itself shows that this is the opportunity that we should look at. Let's move on to the next one, Fred. So now let's take a look at how the market looks, right? So for the claims market itself, is pretty significantly growing market. About 1 billion insured vehicles there are in global markets, and this pool is actually increasing by 3 to 5% per year. At the same time, the claim frequency and the severity of this accident is going by 2 to 3% up since 2014. At least in US and UK, those are the kind of numbers. So obviously, because of this growing the claims and the growing market, the global carriers are under a tremendous cost pressure. If as I said, about 80 million claims per year globally, which is about like a 400 billion dollars into the losses. And if you look at the today's process, and which I said is pretty manual, it's about 95% times these claims are processed manually. There are some virtual tools in the market which are not AI tools, but it does have some capabilities of taking the virtual pictures or the videos, and then based on that, manual reviewers or the desk adjusters provide their estimates. But that percentage is also very less, about only 5%. So considering all of these, the less virtual solutions in the market, about the high manual process, and this LAE about $400 to $600 per claim, right? That is kind of putting a lot of pressures on the global carriers. And if you look at the digital innovation that is happening in this space, right? If you look at 75% of the millennials, they are tech-savvy customers. I mean, even all of us, I'm not dating myself that much, but even we like to use all the mobile apps, and within a 5 clicks, you want to see the result is, whether that's an your account statement on the bank, or your policy statement with the insurance carriers, or for that matter, any other apps that you use. So with the adoption of the virtual tools and the digitization is increasing, right? In US itself, the carriers are offering this digital claim solution since 2017, and the adoption is rapidly growing. About 16% are growing since 2017, which is a pretty good adoption rate. And about customer satisfaction is about 33%. So, with this growing adoption and the technology is available, that's another reason the innovation needs to happen in this space. Let's move on to the next one. And also let me know, Fred, on the time-wise, how I'm doing.
You're doing fine.
Thank you. So now, how is this AI is revolutionizing this claim processing, right? It is, I mean, according to the research, and even from the feedback that we are, getting from the customers, we are seeing that we are able to reduce this claim processing time by about 50%. And I'll get into the details about how this time can be reduced, right? The claim cost itself, which actually goes into the towing, the storages, the tear downs, the replacement rental fees, and all that, that itself is going to reduce by about 50%. Your those overheads can literally comes to 200-ish kind of in dollars, as compared to $400 to $600 per claim. On the top of it, with the AI, you can actually reduce the human biasness, or literally eliminate the human biasness, because two human beings, they do not agree on to certain damages when it comes to the accidental vehicles, right? Even a same person would look at that damage on one day, and another day they probably can change their mind whether it is medium damage versus the high damage or the low damage, right? So with the art of the appraiser, I always call it as an art of appraiser, because indeed it is an art. It's not easy to appraise or estimate any vehicle, accidental vehicle. So taking that art, combining that with the power of the technology and the computer vision, you will always get the consistent accuracy and consistent estimation on any of these vehicles, right? So that's a huge advantage. As I said, the digitization is increasing, the digital adoption and the virtual solutions are getting increasing. That gives a great customer experience, because you don't have to follow up with your garages. You do not have to follow up with your insurance carriers about what happened to my vehicle, what is my verdict on my vehicle. You can instantly literally get that all damage assessment and estimates, and the final estimate on your for your vehicle literally within a seconds, not even a minutes. So that's a great customer experience, and that can be used by the insurance carrier to have a customer retention. Right now, because of the customer experience, many of the customers go to the different modern carriers, right, who offers better tools and technologies. So having every insurance carrier use this kind of technologies, that gives an immense advantage for them to do the customer retention. Next one. Now, I think this is a duplicate slide that we have. Yes. Okay. Yeah. All right. We got. Now, how the process works, our process should work, right? Fairly simple, right? Literally from the ease of use, it should be a mobile app, right? Which should be a customizable mobile app that can be used by any of the insurance carrier, integrate into their existing mobile app, because many of the insurance carrier do have their mobile apps which they provide to customers like you and me, for giving the policy information, account information, and ID cards, and so on and so forth. But at the same time, they provide some claim reporting functionality, and that's where anybody who gets into the accident can just click on that claim reporting functionality, which can fire up the this AI app, which actually guides a user to take the pictures or the video, right? Where to stand, how to take the pictures, which angle, how much you should zoom it. It should automatically adjust the light intensity and all. So customer really doesn't have to apply, let me use their mind, and let the app guide them. So you take the pictures and that's it. You just fire it up, you submit those claims, right? The AI engine, which actually sits onto the cloud, does all its magic. It actually validate those images. Are those really the vehicle images or the non-vehicle images? Like somebody will try to just upload some picture of, let's say, a tree or a table or an apple, right? It should not allow a customer to do so, and it should only accept the the vehicle images, right? So the AI engine does all that validation. It figures out where the damage is, where, first of all, it figures out where this position, this picture belongs to. Is it the front of the vehicle or the back of the vehicle? You don't even have to tell the app that you're taking the pictures from the front. The AI figures it out on its own that this picture belongs to the front left of the vehicle, and this is the, the rear of the vehicle and all. It also estimate how severe the damage is. Is it the body frame damage, right? So that's an high, or it's just a metal ship damage, which is many of the cases a medium severity kind of a damage, or is it in low severity where you have ability to determine the cosmetic damages. It literally identifies all the exterior parts of that vehicle which is seen in the picture. It gives you the details about your bumper has 2 dents, one hole or a crack, and 5 scratches. It literally identify or go to the precision level of that nature. So based on all of these analytical details that the AI gives you, you would be able to actually get a line by line estimate, right? So you get the total repair cost of that vehicle. Then you look at what is the make, year, model, and the mileage of that vehicle is, and what is the ACV of that vehicle. So based on all of those details, you would easily able to determine, is that a total loss vehicle or a partial loss vehicle? If it's a partial loss vehicle, you already have all the exterior line by line items which needs to be replaced or repaired, because based on the damage assessment that the AI is providing you, it also tells you whether that part needs to be repaired or replaced, right? So right now, when you are doing all of this manually, right, and spending about, let's say, imagine 3 to 5 days just to provide an estimate, it would just do it within a second. Literally, if you within 10 to 15 seconds, you should be able to see all of that, right? Now the question literally arises, what about the hidden damages and the supplement? So yeah, the technology is not that mature yet to have the hidden damages of all sort of nature, but still from the impact that the AI is giving you right now, it does give you whether there are hidden damages like 30 to 40% damages inside, right? Obviously, with all the parts, you are getting the associated part. So when the AI tells you that your bumper or the the front bumper is damaged and it is a severe damage and it needs to be replaced, obviously it also tells you what are the different parts that needs to be replaced along with it. And with a hidden damage indicator, which is 30%, you can easily tell them that there is a radiator inside which might be broken as well. So even to some level, you would be able to avoid this supplement that goes back and forth with a manual process. The other beauty of this is about 60 to 70% of the accidents, right, that falls into the low to medium category, right, where you would just need to know how much your repair cost is, and if that repair cost is below your deductible, right, you don't need even a human intervention to settle that claim. You can literally push this claim through a state process, through kind of an process where your customer would be able to get their claim settled within few seconds. That's a huge plus, right? So that's how the process is. Even the mobile app should be configurable, right? So at the beginning of this stage, right, a lot of people are looking at this technology with some, I mean, they are trying to test the water because the technology is still maturing, right? So you definitely need somebody who wants to eyeball these AI estimates, right? So that can be provided on the dashboard, right, where that car and the laptop is been shown, right? So even the desk adjuster that you will have, they would be able to look at that. They would be able to provide the feedback, because it is possible that the AI may miss out on something. It may just miss some, the fender bender, let's see, right? And the desk adjuster, he or she should be able to provide a feedback saying that AI missed this, and in this picture this is what it needs to be recognized. So that feedback that the adjuster gives, right, it goes into the AI algorithms back again, and that's how the algorithms learns and becomes more and more intelligent, or genius, I would call. So that's how easy the process is, and that is how efficient the process is. So let's now move on to the next one. Now, how it yeah, just keep over to the next. Right. So now how this what is an AI, and how it can literally simplify this process, which seems to be very complicated when we are doing it manually, right? So there are multiple part of the AI. AI is a buzzword, but within the AI, right, uh, at a high level, you can say that artificial intelligence it can sense, and it can reason and act and adapt based on what it looks at, what kind of a data it is looking at, right? It gets into the two kind of in categories, where you call it as in machine learning, and another one is in deep learning, right? So within the machine learning, you basically look at the large amount of the data, and then you improve your performance. I mean, when I say you, it's an algorithms. It looks at the data. So just to give an example, let's say you have multiple claim estimates, right? Where you're looking at basically this part and that part and their cost, right? So that's a non-image data, right? Where you can use the machine learning algorithms, and it can learn from, okay, this part, a bumper usually costs, let's say, $1,500. I'm just throwing some amounts there. But using the machine learning, it gets expert. So whenever the bumper comes, it can say that it is going to cost you 1,500, right? When it comes to the deep learning, it is more of let's imagine, I always apply this analogy of our brain, right? Our brain has millions of the neurons which actually construct and deconstruct a lot of images, right? So for example, a cup, we look at the cup since our childhood, and we go through millions and millions of the cups throughout our life. And the moment the cup comes in front of us in any shape and mode, it tells you that it is a cup. The same analogy is implemented using the CNN, which is called as a convolution neural network within the AI. So these neural networks actually senses different colors, the textures, the patterns, and it is able to basically identify all these different type of vehicles and the images, and the damages, and the different shapes of the vehicles. So that is how the overall AI technology works. Fred, do let me know if I'm going too fast, so I can slow down.
You're just fine.
All right, just making sure.
Yes.
So now, as I said, right, it is just like a brain that it goes through. So look at this specific example, right? How does an AI or the deep learning algorithms look at all these images? So it goes through a multiple filter level, or we call it as an activation or the maps. I'm trying to use as many as layman's terms, so that it is not too technical, because I do understand in audience many of the people do not know all the jargons, all the technology jargons. So how this algorithm works, right? So all these algorithms basically look at the multiple activation layers, right? It is almost like an X-ray image that it takes through. It goes through a lot of sampling and down samplings, and multi-dimensional mathematical models to compute these different complex neural networks. And basically it shows you the second row, or the third row, that where you see a kind of an heat map, right, where it is showing you that the bumper and the part that below headlight is broken, right? And how, when it goes through the multiple activation layers and the feature sets that it is looking at, right, it kind of gives you that heat map, and it shows that there is a damage there, that part is missing, and that's the bumper kind of a thing, right? So that is how these neural networks works. There are multiple ways of configuring these neural networks, and depending upon what kind of a use case that you are looking at, whether you are just looking at the classification or you're looking at this kind of an detail level analysis, and the algorithms can be transformed or optimized rather. Move on. So what can be achieved out of these different neural networking algorithms, right? So you obviously can basically identify all the damage severities, right? You can basically look at any of the pictures, any of the positions on the picture as shown in that illustration above, and you can basically predict the damage severity. You can do the position detection, right, where these positions with particular these vehicle images belongs to, right? You can determine the total loss predictions, and that total loss also can be based on your historical data, or you can literally generate this line by line estimate and looking at the ACV, and you can determine the total loss. You can also determine the total loss just by looking at the images. There are millions of the total loss images available that your algorithms can be trained, and just by looking at the images, you should be able to determine whether it's a total loss or not. You can generate the gross repair estimate looking at your historic claim estimates, right? Many of the people trying to do that, there is a flaw in doing that, though. Let's say, for example, there are some Toyota Corollas which are from 2010, and the repair estimate during the 2010 was X amount of dollar, right? Now in today's in 2019, that X amount has grown significantly more, right? So sometimes just by using the historic repair estimate probably could throw you off, and that's the reason you have to use the advanced AI technologies in order to get the today's prices, and use the AI and the computer vision just to determine the mimic the appraisal's mind, I guess. You should be able to use the AI for identifying each part of the vehicle, right? This is how the bumper looks versus the door looks, and the mirror looks, right? You can you can identify the damages such as dents and dings and scuffs and the scratches. It's a very challenging problem to solve, because it's like finding a scratch on certain vehicle, which is, or let me call it an image. The image itself could be thousands of pixels, and within the thousands of pixels, if you are literally looking identifying the scratch, it's kind of an needle in a haystack, right? A very challenging problem is hidden damages, but that also can be determined using these AI technologies. The injury prediction is another one, right? How fast the impact was. You can basically get that from some of the data, G-force data and all, and you can determine the impact, which angle the impact had happened, how the the impact was, what was an object that the impact had happened. Was it just a car, or was that vehicle bumped on the tree or something? Based on that, you can even determine how injured the person inside is, right? Would he be having the back pain or the neck pain, and so forth. So that can also be determined. Another one I already mentioned about line by line estimate, right? So by identifying each parts and their repairability and replaceability conditions using the AI damage assessment, you can literally generate these the preliminary estimates instantly, right? Another one is the telematics. A lot of people are playing with the telematics data, right? Many of these connected cars now have this black box that I call it. You can get a lot of important data out of that, which will give you an ability to determine whether some of the computerized part, or for example, the sensors or the powered mirror, are they working after the impact or not, right? And that's where the telematics integration comes into the picture. Move on to the next one. Right. So how this overall architecture and what are the different technologies is getting used in achieving all of this, right? So technology wise, there are many technologies that is, some of those technologies are literally open source and you can use those technologies, right? There is TensorFlow by Google, OpenCV, there is Python, Keras, all these are basically the AI technologies that is available today in market, and then you can use those to implement what use case that you are you are basically solving, and what kind of different algorithms that you need to use to solve those use cases. But these are the technologies that you can basically use. In addition to that, the legacy technologies, they are not going anywhere, right? So you can, in the sense, although those are the legacy technologies, that those would be used in addition to these AI technologies, right? So how the architecture wise, how the deployment works of all these technologies, right? All of these, everything is on cloud, right? There are cloud providers like, for example, Amazon, AWS, or the all the Windows or Microsoft Azure, right? These are the cloud providers who provides you a powerful computation servers, I would say. It's called as GPUs, which generally used in order to process all these huge amount of data and the images and all. The data itself is in terabytes and multi terabytes, I would call. So you need a powerful computation to process all of this. Literally up to last couple of few years back, those technologies were not available, and that is the reason we were not able to basically solve this problem or automate this problem. But having these technologies available now, we should be able to use this. Behind the scene, there are several databases which can be used in order to basically do the price calculation, because every market, whether that's US or China or Asia, Asia or Japan or somewhere, you should be using a different price catalogs, right? So you definitely need a powerful databases sitting behind that you can use, right? So all of these technologies are cloud-based. You do not need to basically deploy this on your in-house infrastructure, or so those are the kind of technologies you can use easily. Move on to the next one. So now how this damage analysis process work, right? Because although there are technology, there has to be a process which needs to be followed in order to get a certain accuracies, right, or a certain problem solved. So when all this data getting collected using the pictures, right, it could be from the mobile, it could be from any other sources, right, all of those pictures goes through the back office tools, right, where you have to basically filter this data, because not all the data is compatible with the AI algorithms, right? At least till now, these sophisticated apps or tools were not available. So many of the imagery or the image data that we generally get, right, has a lot of noise into it, and that noise needs to be filtered. You have to have the expert on your team who actually and first of all, you have to have the tools onto your in your team, which can be used to filter this data, right? And then you have to have the subject matter experts who actually understand this space well, who actually looks at this data, do all sort of an annotation on this data, and then push it through the algorithms. And then the algorithm starts figuring it out, what is that it needs to predict. There are certain mechanisms called confusion matrix. I mean, those who are into the AI space, they would certainly understand what confusion matrix is. But the way that algorithms looks at all of this data is where you are seeing those populated dots, right? If you can hover your mouse on that, Fred. Yep, that populated area that shows you that your prediction or your estimations are in a ballpark or very close to what you're looking for, versus the dots which are far away from that populated mass, right? Yeah, those are literally not falling into the ballpark estimate. So for example, let's see a very simple example, looking at a position of the image, right? On that on the left hand side where you see that car image, right? Let's see, this the front left of the vehicle. Again, I'm just giving an example. So when you put about, let's say, 1,000 pictures into your algorithms, and your confusion matrix is basically predicting out of that 1,800 pictures into that populated area. So you would say that yes, I'm 80% accurate, versus there are some other vehicles which are changing in the little bit of an angle, and it is falling far from that populated area. And then you would say that, let me take a look at all of those those other vehicles which are not coming into this ballpark. And that's how you basically come to the conclusion where you need to change your algorithms, how to optimize your algorithms, what architecture, neural architectures that you need to use, and thresholds and all that stuff, right? So that is how the AI technologies look at, and then change their approach in order to do the predictions. And obviously, once you're done with that, what you call the improvement or optimization, you should be able to start showing the result to the users. And obviously there are dashboards that are available on the front end. You can also display these estimates on your mobile in itself, all through the APIs, because all of these predictions or different use cases that I spoke about, everything is, bottom line, everything is algorithm. Every algorithm is wrapped up into the APIs, and all those APIs can be shared with anybody from on the front end or on the even on the back end, right? So that's how the overall damage analysis process, or at a higher level, the AI analysis process works. Move on. So now we just spoke about the auto insurance claim so far, right? But there are the natural progression within the P&C industry that these technologies can be applied, right? The natural progression would be obviously the examples or the technologies that I have spoke about was more towards the personal line of business, right? Like in sedans and all. But the same can be applied to the commercial lines, right? It can go into the two-wheelers, right? The Asian market is very high in demand from the two-wheeler standpoint of view, right? They lose more money into the two-wheelers claims rather than the four-wheelers, right? So that becomes another opportunity to look at, right? Injury prediction I already spoke about. The same technologies can be applied to the housing and the commercial properties, right? You can literally use the drones to take the pictures of the property, and you can use the AI algorithms and AI technologies in order to do the assessment on the houses. Same thing with the boating, right? So the it's limitless, right? I mean, you can expand and extend these technologies to many of the verticals within the insurance industry. One. So I touched base in a little bit on how the damage analysis process works, right? So same thing. I mean, this slide more of into the same direction. That how does the image data and the non-image data gets into the algorithms for the optimizations, right? So it ultimately goes through all the back office tools where all these images gets filtered, their qualities get analyzed, it gets annotated. Same thing with the non-image data. When I say non-image data, it's most of the estimates and the pricing and the listing of the parts and all that I'm talking about. That also gets through all of these tools and the experts analysis which ultimately gets into the algorithms, and the algorithms get trained on these on this data, and then start the estimation or predictions. The overall period for this process, right, is about 3 months to 2 to 3 months, just to take the data and then start the onboarding process for the client, right? And as the technology is improving, as the more and more automation is happening on the back office side, that time frame is reducing, right? At some point, literally, there are like within 2 weeks, we can literally do the first level of the proof of concepts kind of. But that's how the model training and optimization works to accelerate the onboarding process. Move on to the next one, and that's the that's the end of this presentation. So I hope that this whole presentation makes sense to you, and at least I'm able to basically speak about, or how insurance industry needs this technology and can get benefited. So now I think Fred, we are open for questions.
Thank you so much, Raj. That was a great presentation. We've got a couple of questions here. One question is, at the very beginning, you spoke about customer satisfaction numbers. Someone's asking, where did they come from for the photo estimate process?
Right. So we have done research on these numbers, right? If you can go back onto that slide, probably we can speak. So there are reports available, if you can research onto the NADA side or any other.
This is probably it.
Right. So all these numbers are available. If you look at that, the data is coming from NAIC. There are other research reports that is available by JD Powers, by Capgemini and all. So those are the numbers that is coming from those, right? So if you look at that 75% that is coming from Capgemini, if you look at the numbers, adoption number of 16% growing rapidly, that is coming from JD Powers. So all these numbers are researched and proven and available on the internet if you look at, and I'm more than happy to provide the links if somebody wants to have.
Okay, second question, thank you. Second question, does AI take into account OEM procedures?
Right, so OEM procedures can be taken into the consideration. Right now, it is not included into it. But if I touched base a little bit about the schematics, right, or the associated parts, that the term that I have used. So in terms, it does consider that portion of it, but is it actually learning out of how the fender bender needs to be replaced versus repaired? No, it is not.
Okay. All right.
Eventually, it will be though.
Yes. All right. How many images, data sets are necessary to have a high degree of confidence that the damage assessment is within the acceptable sphere of accuracy? Damage. I'm just trying to read this question. It's a long question. And estimated repair costs.
Right. So I understand. The answer to that question, and this goes kind of an across the AI industry, more the data, more the accuracy, right? That's the kind of an mantra. But overall, if we say that, let's assume we are looking at the total loss repair estimate use case, right? So at least you should have a year worth of data. If we look at, of course, one thing that is important, that data should be diverse. It should not, because otherwise the AI is going to be biased towards one single model versus the other. So if you have a diverse data which comprises of all sort of damages and the estimates, a year worth of data should be good enough in order to get at least, if not more, at least 80% of an accuracy. Okay. But more the merrier, I would say.
There's a question about a scratch or a line. How does it detect the difference between a real deep scratch and just a superficial scratch?
Well, it depends on how you want to train your model, right? So the details, how detailed you annotate those kind of damages, right, and how detailed your algorithms are looking at. I mean, of course, there are some trade secrets and proprietary ways of doing it, but it depends on how you annotate your data and how you train your algorithms and how you create your architectures, your CNN architectures.
Okay. All right. I think we've got a last one here. Is how are you determining the repair or replacement costs for the gross repair estimate?
Right. So now there are repair and replace, right? The decision differs for every market, every state, right? So there has to be a business engine which actually takes the data from those parts of the or those market regions, and your algorithms needs to test. The approach that we have taken is, depending upon the type of the damages, right, you make a decision on repair or replacement of that particular part, right? You also consider the I don't think that slide is in there, but
Gotcha.
you also take the labor cost and the labor time into the consideration. Based on that, if you have to determine whether you want to replace that or the repair that particular part. Many of the cases, right, in US, some of the parts that we probably will replace, those part gets repaired into the other part of the world, right? So the way that we have constructed this business engine is it takes into consideration the needs of those markets, and then the algorithms get trained on those that kind of data, and then it predicts whether it is repairable or replaceable.
Okay. I've got I think one last question here, and it has to do with the data itself. Does the insurance company have to provide its own data, or I mean, I imagine that the more data that gets processed, the more images, images of accidents, the smarter the engine gets. Uh, but so that is that the historic images come from a single, or or do you have your own database that does this, or is there an industry database that does that?
Well, I'm not sure whether there is an industry database, but we definitely have our own database, and it is, hundreds of thousands of and millions of images that our algorithms are trained on, right? So definitely we have our own. In some of but there is another, addition to that answer is, in some of the regions, right, the if our algorithms have not seen certain kind of images. So for example, many of the images are look alike, right? Honda Civic may look alike Toyota Corolla with little differences. So we already have that data store. Our algorithms are trained on those. But let's see, for example, and this is a classic example I always use. There is a car called Nano, which is manufactured by Tata in India. That is an unusual vehicle. It doesn't look alike any of the other standard vehicles that we have, right? In that kind of situation, we say, we do not know this vehicle. Our algorithms have not seen it. So can you please provide that, right? So that's when the insurance industry, insurance carrier can provide that data, and the algorithms can be trained. So it could be multiple sources of the data that can be combined, or our approach is, give the algorithms to that insurance carrier specific as well. So they don't have to use a generalized, and they will use their own algorithms trained on their own data.
Okay,
I
great.
hope that answered the question.
Great, that does. Okay, this concludes today's CIECAst. Please check out our lineup of CIECAst for 2019 by visiting the events tag on the CIECA website that's up here. Also on that tab, you will find the annual conference, Connects 2019. It will be held on September 16th through the 18th in Charlottesville, Virginia. Please go to CIECA Connects, CONNEX.com to register. At Connects, in addition to the informational sessions, There will be a tour of the CIECAst, the Insurance Institute of Highway Safety facility. This is one conference you will not want to miss. If you're interested in receiving AMI credit, please visit the AMI website and take the quiz there. Don't forget to follow us on Facebook, Twitter, and LinkedIn. Thank you for keeping abreast of today's CIECA developments. Our standards are built by our volunteers from all industry segments. For those that have contributed to our standards, we thank you. If you have not yet been involved and would like to participate, please contact Charlie Quirtz, Stacy Phillips, or myself. As always, the video of this presentation will be available on the CIECA website within 48 hours. Again, thank you, Raj, and thank you, our audience, for participating. Have a great day.
Thank you so much, Fred. Thank you, everyone. Thanks.
Thank you.